Perfect Plumbing Plan, a Build Original series brought to you by SharkBite.
All right, we're back, guys. We solved, hopefully, the problem of time to tap. Now what are we doing, Eric?
Well, we're going to talk about not running out of hot water. One of my customers' biggest complaints.
The second complaint you get.
It is.
So we're talking about hot water heaters, right, Eric?
No, we're talking about water heaters. We're going to heat cold water. No, I love it. Water heaters are different all over the country, right? Depending on kind of your region, the fuel you have at your house, or what you want to have, right?
Yep.
In my market, tons of gas water heaters. We see them all over. We're doing them retrofit and new installations, okay? We've got high efficiency gas water heaters. We've got some lower mid efficiency gas water heaters being installed maybe in the retrofit market.
Gotcha. Down here in Texas where I am, super hot. Makes a lot of sense. We actually have quite a few of these in the studio because I talk about them a lot, to do heat pump water heaters. I was one of the early adopters from one of the very first models in 2008 or 9. I've used them a ton since. I really like them.
Yeah.
What's Boston like for you?
Yeah, so we see some heat pump water heaters being, moved into the industry. I think part of it is the electrification movement. So for some homes that they want to add solar, they want to electrify. There's some rebates for these heat pump water heaters, so they want to move to that. But they also steal heat from the room that they're in.
Yeah.
So we want to be cognizant of that. So if you have an all-electric house, it's taking the heat from the house, putting the heat into the tank, and rejecting cold, dehumidified air.
Yeah.
So it's a really good air conditioner and dehumidifier, which is why it's really good in the south. That's right. But in cold climates, you have to be concerned about that. That's one of the knocks and one of the things you have to be concerned with.
For sure.
But they do work great,
All right, so you guys watching this, our number one concern is how to not run out of hot, right? How do we make sure that you don't get that call back? We're gonna be talking about gas and electric. We're gonna be talking about tank units, and we've got tankless, both gas and electric. And remember, whenever I say gas, I mean that generically. It could be natural gas or it could be propane. And we might even quickly touch on geothermal on a couple photos. But
yeah,
Ross, let's start out with talking about tank type heat pumps. We've got those kind of forefront in our mind. First off, before we even talk about this particular unit, tell us the difference between this unit and a traditional electric tank.
Yes. So the first thing you notice is much taller, and this top section is the actual heat pump. So it's got a compressor, a self-contained refrigeration process, and it's taking the heat through these two outlets, right? One goes in, one comes out, sometimes side discharge, but it's stealing the heat from the room that it's in, putting that heat into the tank.
Yep.
We also have electric elements. So right here, there's a top electric element, and there's a bottom electric element that can be serviced. And so that's what you would see in a traditional electric tank type water heater, just these two elements.
So if I could kind of compare it to another appliance we're used to seeing, a hair dryer uses electricity to heat up that air really fast to dry your hair. That's kind of what an electric tank, a standard electric tank is. It's basically a hair dryer that heats the water.
That's right.
These are more like your refrigerator in the kitchen that runs a lot and steals heat and dumps it. Now, these are the opposite of a refrigerator. Rather than the way that cycle works, this is the opposite.
Yep.
But much more efficient. And how much more efficient are these than standard electric tanks, would you say?
Yeah, so a standard electric tank type water heater is going to be somewhere in the 0.95 to 0.98 range.
Okay.
It's close to 1, right? So you put $1 in of energy, you get $1 worth of heat out.
Yep.
With the heat pump, you dramatically increase. So that's this one right here that's rated in UEF, which is Uniform Energy Factor. The UEF on this unit is 3.2. So that is basically 3 times more efficient to run the heat pump than it is to run the electric elements.
So one of the things I want you guys to remember is that we're making this video today, but I want you to pay attention to what Ross and Eric are mentioning on specific stats, because these models may not be made anymore when you watch this. There may be 5 new manufacturers that make new models. Right. So that first thing I really want you to key on is this UEF is really important, and is a good way to compare because you're going to see different numbers on these tanks. So this one is $3.2 of hot water for every $1 that goes in.
That's right.
That's the beauty of the heat pump technology. So this, in effect, is 3 times more efficient plus at making hot water than the standard electric tank. And that's why we love these heat pumps.
That's right.
So much. So what else do you look at?
So this unit runs on 120 volts. It's basically a plug-in unit, right?
Fascinating.
Into a normal receptacle, 20 amp circuit. And so this is very different than some of the other electric tank type water heaters, or even the one that's over there, which is 240 volts. So it has basically 2 hots. So it would not wire with a regular plug.
So Eric, with this one that runs on a standard plug, what's the usual use case for a plumber in this one?
Actually, what I think this is actually made to do is to replace an existing gas water heater where you don't have a high amperage circuit to an existing electric water heater, but you do have gas and you can easily get power to that location.
Yeah.
Right. So having a nice long cord there, it's actually a GFCI cord, so it meets all the specs for electrical codes. And it's, besides its physical form factor, it's going to pipe in very similar to an existing gas water heater.
Yeah, you get your hot and cold up top connections. You got your in and out from an airflow perspective. One thing that does get forgotten about is the condensate drain that you don't have on a traditional gas water heater,
It's
right?
going to drip a little bit of water out.
That's right. So
you
you
got to
have
figure
a
out
place
what
for
to
that.
do with that.
That's right.
Yeah.
So in a basement, it can go right to a sump basin or sump pit, maybe a floor drain, but that is something that you have to plan for if you're going to switch from a gas water heater to a heat pump water heater.
Now back to the original intended purpose, not running out of hot. How do you figure out how much hot this is going to make, and how do we compare that to other units?
Yeah, so this unit right here is an 80-gallon model, so it's an 80-gallon vessel, and it's going to give us a first hour recovery of 93. So one of the things that we're looking at is what is actually the first hour rating? How much hot water can I get? And that's 93 gallons per hour.
Okay, so FHR, this one's a 93, and part of that is because it's got so much standing water ready to go. It's waiting for you to take your first shower.
That's right.
That we can get 93 gallons.
That's
and
right.
relate that to, I don't know, I know this, I'm putting you on the spot here, but like, you got a family of 3 or 4 in the house.
Yeah.
Does that feel like that's enough hot water, or are you worried about, oh, I don't know?
Well, if you think about it, right, so like take a traditional shower head, right? It's going to be somewhere between likely maybe 1.5 to 2.5 gallons per minute. Let's just say 2 for just this example.
Yep.
So 2 gallons a minute, that means 2 gallons come out of the shower head every minute. Now, if I have that one shower running for 10 minutes, that's 20 gallons.
Okay.
So if I put that into perspective, if I have multiple showers that are all 10 minutes at a time, compared to the 93 that I have available to me, I can actually run quite a long shower or multiple showers back to back without running out of hot water. You think about just 20 gallons, 20 gallons, 20 gallons, 20 gallons, 4 people, 10-minute showers. I can still do that.
Yeah, probably fine. Now, on the other hand, if you have a teenager who takes an hour-long shower and then another teen gets in, they may run out.
That's
I put him on the spot of those numbers. He did pretty good, didn't he?
But the other thing too is the mode of operation. You can set the controls on most of these units. Do you want to run on the heat pump only? Do you want to run on the electric elements? Do you want to run on the combination of the top element and the heat pump at the same time? So you can basically pick and choose how you want it. So there's sometimes they call it econ mode, sometimes they call it hybrid mode, sometimes they go electric heater only mode.
Yeah.
So it really depends on your behavior in terms of how much hot water you're using.
Makes sense.
Ultimately, the most efficient is going to be in heat pump only mode. Okay. Difference between this and the one next to me, however, they both have the electric resistance elements, right? Standardized an electric tank typically. And we're seeing that in pretty much every heat pump water heater we're out on the market, unless it's heat pump only, but most of them are hybrid, which allows the heat pump to operate at the same time as one element.
Okay.
Difference between the two, though, being that's a 120 volt model on a 20 amp circuit, it has 900 watt elements in it. This has a standard 4,500 watt element.
Quite a bit bigger.
A lot more juice.
A lot more juice, a lot more electricity, which is interesting because this is actually a 50-gallon model they sell it as. It's actually, like, in reality, it's 45 gallons, the specs on it.
It's a nominal 50, they call it.
Yeah, they call it a 50-gallon water heater, which we see that in different brands and different models all the time. There's reasons for that. Yeah, it's close. It performs like a 50, so that's to their credit. We'll call it that. The hybrid mode is what we're leaving most of our water heater installations in my company. And what that does is it prioritizes the heat pump, but allows the simultaneous use of the electric element, giving a little bit more higher recovery. And that's our biggest problem with heat pump water heaters, recovery.
Now, what is this one off the hand?
The first hour rating is 68 gallons. It's a 50-gallon tank, or 45, and it give us 68 gallons. So a little bit higher if you do the math there for storage volume and first hour rating percentage-wise between the two.
Yeah.
That's because we have 220 volts, right? We can
You have more juice to pump
we
in.
apply
if we
more
need to.
energy to this element, get more water out of it.
Makes sense.
A couple things about this that I notice as a plumber, though, is especially for retrofit, right? I don't do a lot of new construction, do a lot of retrofit. Side connections on this one. We don't have any pipes on the top.
That's nice.
Yep.
Yeah, whereas
So
this was
that being
piped
more
up
of
top.
a retrofit model makes a little bit more sense, especially if you're working in a market where I am, where you have basements. Pipes coming from the top.
Yeah, that makes
Makes
sense.
it easier for us to install, right? Side application. now we need a little bit more room left to right, or we have to position it right just so we can get the pipes in there.
Yeah.
A little bit of
One of the key differences too is height. Some of these units do get really tall. So in really tight basement spaces, sometimes we don't have enough piping connection and access off the top. And sometimes we don't have enough serviceability on the top of the unit and for airflow and to service the top of this unit.
Yeah, and notice the diameter size on this thing too. I mean, this is a pretty big unit, and this one's a lot more of a traditional 50-gallon tank size. It's a little more compact. But don't forget, these are stealing the heat from the air. So you can't put this in an enclosed closet. This needs to be in a bigger, more like a 10 by 10 closet at a minimum. Most of these have specs that say we need a 10 by 10 by 8. What are you about to say? You're about to jump in here on me.
No, I love that you brought it up, because this is one of our biggest challenges as plumbers out in the field, okay? Or HVAC contractors, whoever's putting the water heaters in. We have to consider that first, because if I install this in a space that doesn't have enough energy for it to operate properly and efficiently, now I've given you an appliance that isn't going to perform the way I said it would.
That's right.
Right, that's a problem. Also, expelling that cold, dehumidified air into the space can be a comfort issue.
That's right.
So we don't want to put ourselves in that position. So we have to consider that first and foremost. Whether or not a heat pump water heater will work for my customers is whether or not we meet all the specs, check all the boxes for volume. That's really number one, because we're in a heating dominant climate. You brought that up at the beginning of the video.
Sure.
Heating dominant climates, we don't want to steal all of that heat that we have created, but also we need to be able to put this cooler air somewhere in the middle of winter.
In my case, if I put these in my garage in Texas, I've got a free amount of AC in my garage. Garages are typically very hot in the South. So these are a great fit for the South, especially in a garage, a secondary space.
Yep.
But I can see why they may not work for everybody. Let's move on from these tanks. We're going to talk about some gas tanks in a minute, but I want to get some advice from you guys on these two tankless units behind me.
Sure.
So Eric, I know you've done, I'm going to switch places with you because you've done these more than I have. Talk to me first about the gas unit. That's a pretty ubiquitous thing to see gas tankless out there in America. What do we need to know about these?
A couple things. So they're direct vent appliances. So we have an intake and an exhaust. We're pulling air from the outside for combustion. So we're not using house air. We don't need it. We have no makeup air needs in this calculation for this appliance.
Yeah.
So it's great for new construction, but retrofit might be an issue unless we can get this closer to an outside wall to get that pipe outside. Right. But that being said, it's not going to affect the performance of the house like a heat pump water heater has the potential to do.
That's right.
Right. Now we're not using electricity. It does have a cord. We do have to plug it in, but it's minimal voltage. It's literally to operate a PCU. The cool thing about gas tankless, and what I want everybody watching this video to pay attention to, is we can put them in and we can run recirculation systems on them, but we only recommend using recirc if it's built into the unit. Okay. So for retrofit purposes, or the idea of having that dedicated return line with the recirc pump like in your house, that's great if we're going to connect that dedicated return recirc to the unit with a built-in pump.
Got it.
The reason why that's important is because this is now controlled efficiently, and so we're not firing the unit when it doesn't need to be fired, which is inefficient for it, and it's using energy that we don't want it to use. These things are so smart, they'll actually learn how you use your water and only heat it when you need it.
Dang, that's pretty impressive. Back to you being a service plumber, if you've got an older house that's having this issue of, hey, my hot takes forever to get to me, one of these could be a potential all-in-one solution for you.
I'm glad you said that. My business, we look at the existing power source first, right? If somebody calls me and they want a heat pump water heater, my first question is, can we install one?
Right.
Like, do you have the power source? Physically, do we have the space?
Power.
Do we have the air volume? Are we going to need to duct this to the outside because that volume isn't there? And also, can we even support it at the panel? For gas replacements, though, I get customers calling and say, hey, I got an old water heater. We'd like to upgrade. What are our options? I'll tell you, I'll be completely honest with you. I'm always going to go to tankless first if it's going to be a great selection for a fit for them. It takes up less space. Sometimes that's useful for my customers. They're going to gain a little more space footprint.
Sure.
It's going to be.
Look how much smaller that is in the tank.
Right.
And the idea that we're not storing water, right? So every time this runs is only because we've told it to, and that's by opening a faucet or if it's got to run the recirc line.
Right. If you have a gas water heater, tank type, and you're swapping to a tankless, or sometimes we call them instantaneous water heaters, if you do that swap, you do have to check the gas pipe size. Because this is a 199,000 BTU unit, basically 200,000 BTUs.
It's a lot of gas.
A traditional tank type might be 45 to 75, maybe 80,000 BTUs. So the gas pipe size, might be different. The other thing too that we want to be concerned with is water quality. anytime we're dealing with any tankless unit, they have very, very small passages. If you have really hard water, then you can get calcification and sediment and scaling on the inside of the passageways inside the unit. So something you want to be concerned with as well.
Tankless is less of a good fit in areas that have like high calcium and limestone, magnesium in their water, like
which is
you guys
me.
have here.
And frankly, I don't use tankless as much anymore because of the maintenance issues. It's not that you can't, it's just you really do need to maintain them and flush them, get that calcium out on a regular basis, unless you have a softened system. Now, if you have soft water because of a softening system, then it's not as big a deal. Back to our first issue that we're trying to solve here, which is
not running out
of hot. What do you think about that?
This one, I'm biased. Install a ton of them.
Look at that number, Eric. What is that?
348 gallons first hour rating. Okay, so basically, if you're
So more than triple this.
if you're just doing the math, how many gallons a minute can you run through it physically? And that's pipe size, faucet, things like that. And then there's only 60 minutes in an hour. So this basically is just going to make hot water until you say I don't need it anymore.
Yeah.
You can turn it on today, it'll be running tomorrow.
Yeah, it's pretty crazy.
You basically never run out of hot water with that.
So if we're trying not to run out of hot, there's a reason why a ton of builders like these, because they don't get that call back, and probably plumbers for that reason too,
I think it's worth mentioning there's a lot of really, really smart people watching these videos. We noted that this is 199,000 BTUs. That's as large as most or any gas tankless that I know of goes to, for residential models. They don't have to be 199,000 BTUs. These are modulating, so they'll only fire what they need, however it's capable of, right? They make smaller models.
Yeah.
So if you have a smaller household that we can size these very efficiently, and even the websites that sell these will tell you exactly what you need. Very straightforward, and they're accurate.
Yeah.
Right. So these absolutely do perform, and they don't have to be as big as this. They can be smaller.
UEF on this guy is 0.98, so very, very similar to an electric tank type water heater, not a heat pump style, right? So similar in terms of efficiency there. And these are going to be mostly all stainless on the inside, no anode rod. So just these units have anode rods that need to be changed. This one does not have that. So that's another advantage.
It is.
You know, on the instantaneous.
So back to that UEF rating, I'm curious, this is just shy of 1. So $1 of gas gets me $1 hot water.
Yep.
This one's 3.2. $1 of electricity gets me $3.2 of hot water. But doesn't it matter what we're paying for both electricity and gas potentially as well?
Exactly right, yeah. So depending on where you live in the country, you're gonna have very different rates of electricity in terms of what you pay, and different rates for price per therm or price per gallon for propane.
So for example, per kilowatt hour rating where you live.
So we're about 32 cents a kilowatt hour.
15 or less.
Yeah, it's a lot higher where you are.
Yeah, exactly.
We're probably like 12 or 13 cents.
Well, we've had clients that say, hey, I want to go heat pump water heater. I've heard they're the craze. They're awesome. They can do all these amazing things. So they put in one like this, right? And then they find out that their actual bills went up compared to their gas option that they had previously.
Right.
And so if it hurts the wallet, that's obviously not the best solution.
Yeah.
So one of the things you have to pay attention to is what is the utility rate, both in terms of price per, therm in natural gas or price per kilowatt hour, to put them on a levelized playing field.
Which brings us back to what we said at the very beginning. There is no silver bullet. There is no you got to use this or you got to use that. There's different levels of options here. And that's why we're really trying to tell you what to look for and what to consider with that goal of not running out of hot, but also, frankly, I don't want to pay more than I need to for that hot water to begin with. I want to size this based on what I need for my household, my family.
They all have pros, they all have cons. Yep.
Now, that being said, Eric, there's one on the wall here that I've never used before, and I got to tell you, I feel very shy about understanding this. This is an electric tankless.
Yeah.
Tell me about that. Have you used any of these?
So I'll talk about the performance. I have installed a few of them, and I know Ross is going to have some really great info on the power consumption, right?
Sure.
Okay, so electric tankless operates, let's say for the purpose of this discussion, exactly like this gas, right? Turn on a faucet, it turns on. A couple cool features built into this particular model that others don't have out there, but there's a lot of electric tankless on the market.
Absolutely.
Right. So do your research, see what's available in your market, which ones are being installed and who's installing them. All right. So you get the right contractor. Application is key for electric tankless because they have some limitations. They're not always great if they're oversized, because then they have problems like low flow fixtures. However, it's not typical that we would use this model like a 27 kilowatt. That's a lot of power.
27,000 watts.
Yes. Now
It's a big boy.
It's 112 amps.
It is
Look at that.
112 amps.
It needs 3 40 amp 220 circuits. If you have a 100 amp service, That's going to probably be more than what you have coming into your house.
It is.
It is. However, performance is pretty amazing. So these things can put out a lot of hot water with a very small footprint, not a lot of input. I mean, power input's high, but this very simple install. There's a hot, cold, and there's a power line. That's all there is to it.
Super simple.
We don't have any flue piping. We don't have any use for makeup air. We don't have to worry about cooling down the space.
Super compact units can fit in a lot of places.
Yeah, so these come in various sizes, right? This being large, 27 kilowatts, about as big as any that I've ever seen. But I've seen electric tankless that are like 3 kilowatt, right? So you could put those things under a kitchen sink, under a remote bathroom, and they can even be used in hybrid with other types of systems. So think of the long recovery of the heat pump water heaters. It is one of the complaints I get from customers. They do take a little longer to recover than a standard system. And so you could even hybridize with the electric tankless.
Yeah, let's say you get a couple grandkids all of a sudden in your family and your house goes from 2 to maybe 8 people at the holidays. You could use this guy, but then add this in tandem.
Yes.
So that, oh, shoot, my water level is kind of tepid. Well, then this would take it from whatever the tepid is, 95, up to 105 if they're showering. Instantaneous,
it's like a booster.
no problem. Like a booster.
And it works really well because just like the gas tankless behind me, they only work when you need them. And if it's being fed hot water, it doesn't need to raise the temp. It's not going to turn on.
Smart enough to know all those things.
Yeah.
You know, it's funny, Eric. I know you and I both traveled to all kinds of other countries. The only time I've seen these is typically when I'm out of the U.S. Like my daughter's apartment that she had for a while in Paris had one of these on the wall, and I showered with it. I couldn't tell the difference. I had no idea that the water was coming from electric, but if you go in the kitchen, it's right there on the ceiling, like right above the kitchen sink.
I've been a plumber for almost 30 years. I've never been able to feel the water and say how it was heated. You know what I mean?
But yeah, this is a great unit for even the smaller compact versions. So this is 27 kilowatt, but they also sell different units, right? So you can get a 3 kilowatt, a 5 kilowatt, a 10, a 12, a 15. So if you have that one bathroom at the end of the line, so to speak, and you only want to run a domestic cold water line, right? Because that bathroom doesn't get a lot of use. You can install one of those just to provide local heating for that bathroom group at the end of the line without doing the whole house through a system like this.
That makes a lot of sense.
With a lot less power.
I love the application like you're talking about, farther away. We've seen the increase of popularity with the ADUs, right? So if we're building small, tiny houses in the backyard, maybe adding something like this because power is easier to get to them than worrying about combustion air, venting, all that kind of stuff.
You could put that under your kitchen sink too, and for that matter, or
at a small size,
pantry, right? Because it's so small and compact.
Yep,
absolutely.
Fascinating.
Yeah.
Now we still have gas tanks to talk about, and we have a couple of other alternatives as well. Let's flip over the vibe board and show you some more options.
All right, so we have the gas tankless water heaters, right? We have, in this case, it's vented the outside through a concentric vent. So that's a pipe within a pipe, right? You can do 2-pipe or single pipe. Instantaneous water heating right there. We also have tank type, gas options. In this case, we got 2-pipe going to the outside. As you can see, one white pipe going out, another white pipe coming in. That's how it gets its combustion air. Then you got a nice 80-gallon water heater in that case.
That's an interesting category that I want to make mention of. I've used a lot of these over the years, especially in larger custom homes. This is a high input, what would you call it, Eric? A high input tank, high BTU tank?
Yeah, it's a high input, high performance tank. So this thing will put out a lot more water in that first hour rating than a similar size standard gas water heater.
Yeah, and so it can, in some respects, compete with a tankless unit, but you've got that standing tank.
You've got the dump load or that standing volume. So if you've got high load demand, like dishwashing in a restaurant, something like that, that's really kind of what these were made for. Higher performance, smaller footprint. They work really nice in custom homes that have maybe larger showers.
The body jets, the rainfall shower heads, and all that kind of stuff. We need a lot of water. These work really well.
A lot of energy though, too.
They do, yeah. They do. Running on gas or propane. Sometimes we do an indirect water heater. So there's 2 of these in this case. These are stainless steel tanks, and they have a very, very large coil inside them. And so they are heated from a boiler. So the boiler could be a gas boiler that's providing that heat. It's running like for space heating. That space heating water comes in. That's the 2 pipes that you see here that are insulated. You also have the domestic, which is the uninsulated pipes that are leaving, going through the mixing valve, and then going out.
See these a lot in basements in northern climates, probably a ton of these up in Minnesota where you are. You've got a boiler that's already providing hot water for a floor heat system, for a warm board, for something like that. So why not use that boiler there as well?
Yeah, make use of our high efficiency boilers that are operating in the upper 90 percentile, gas, of course, in most cases. And also, these are super versatile because we can actually connect with certain tanks, we can connect a air to water heat pump system. So we're doing a lot more air to water for space heating in the hydronic market, and we can actually connect and then power up the domestic hot water tank. Indirect meaning the heat source isn't built into it, which is also makes the tank a little more simple, sometimes less expensive, longer term for usage, really.
Yeah.
Ultimately.
All stainless steel in most of these units, right? And a long warranty, right?
That's nice.
Really, really resilient, pretty bulletproof. We use them for many, many projects.
You get a lot of output in a smaller footprint.
That's right. So we also have your regular heat pump water heater, right? So different manufacturers in different markets, same idea like we just talked about here, here, just making sure that we got all the sizing right and that we have the volume and the amount of heat movement through the room and through the space.
You know, one of the things that I want to mention is this unit has, and like all these other ones we had on stage here, has the heat pump right on top of the tank. But there is another option that I actually used at my house, Ross. How about we jump over to my house, guys, and I'm going to show you another option for a heat pump that we haven't seen before. We'll meet you over there.
All right, guys. So here at Matt's house, they've got the water heater in this really cool closet.
I love that detail.
No, that's fun.
It's one of my favorite parts too. Big tank here, elevated up. There's a nice drain system underneath it in case there's ever a problem.
It's actually an 80-gallon.
80-gallon tank. But do you see anything missing here?
You said it's a heat pump?
It is a heat pump.
It's different than the other ones we saw at the studio, isn't it? Where's the heat pump?
This is fascinating to me. So this is just a storage tank. Stainless steel, which makes it even more
No
reliable.
anode rod, I like that.
Yeah, I like that too. As a plumber and doing service work, that's nice. But all the heat is being produced outside. So Matt, can you just tell us how that kind of works?
Yeah, so this is pretty cool. It's a split system.
Yep.
So the outdoor unit looks just like an air conditioner condenser, right? It has a fan.
Looks like a mini split.
Looks like a mini split. It's kind of sized like a mini split. But what was crazy was during construction, I had to drill 2 holes, and I've got, I think they're just 1/2-inch pipe, PEX A, running through my zip on the outside that I insulated getting there, and I insulated outside, and I put heat tape on it because I'm
domestic
smart.
cold going out, domestic hot coming back in.
Exactly.
Heat taped.
Yeah.
I want to show you a couple cool things about that though. So let's go out there.
Let's go outside.
All right, guys, this is the outdoor unit. We've got the hot and cold pipe connected to it. You'll look at it, and like you said, it looks just like a mini split. Yeah. It's got a CO2 refrigerant charged into it, and it's a monoblock system. So that water isn't mixing with any of the heating circuit. It's a heat exchanger built into the unit.
Yeah.
And the pump is out here. So inside, there's just a communication cable. No power to the tank, nothing like that. All the power, all the mechanicals are out here.
Yeah.
Pretty cool.
Yeah.
And
I love the fact that it's CO2 refrigerant, right? A natural refrigerant, GWP1.
Yep.
Also self-contained. The fact it's all self-contained in one box, a monoblock style. And then I do get a little bit worried about the domestic water coming outside.
Yeah, that's not Freon, by the way.
Yeah, in cold climates. That's domestic water right there, cold and hot. So I do get a little bit concerned about that.
I tell you what, though, I've installed one of these myself, right, on our friend Jake Bruton's project in Kansas City. So colder climate, no problem, awesome performance. And as you know, super fast.
Super fast.
The cool thing about their CO2 refrigerant is the heavy lifting it can do. It can raise that temperature of that water extremely fast and charge that tank. You've got an 80-gallon tank. That's huge. I would suspect you could go smaller and still not have a problem.
Don't forget, I have 4 teenagers in the house, and I have yet to run out of hot water. I've lived here 4 years.
This thing's capable of making water up to 150 plus degrees.
That's one of the reasons I liked it, because I figured I could set it at 125 or 130, and if I did start running out of hot, I could bump it up. I haven't had to.
No.
I haven't needed to. And I wonder if it's because it's so quick at recovery.
It is. It's a really super efficient system. The heat exchange between a refrigerant system and water like that, it's very simple. It's not complicated.
Yeah.
It's very fast.
You can get a 50-degree or higher temperature lift in terms of delta T, they call it, difference in temperature. So if I've got 50 degrees coming into it, I get 100-degree water or more coming out of this in a single pass.
Wow, that's amazing.
Yeah.
The other thing I want to mention too, don't forget guys, in the south here, our inlet temperatures are really warm. I mean, if you guys have been staying at a hotel nearby and you turn it to cold, it doesn't get very
75
cold.
degrees.
I can't even get a cold shower here, which is crazy.
You can't. I mean, a cold shower here is inlet temperatures around 60 to 65. And a lot of times it's because we've got these long, tall towers that we keep our water in that are stored outside. It's 105 out. That tower's getting hot. Then it goes underground and goes to houses, but it just never gets very cold.
Right. Yeah, your water lines are really close to the surface too. Ours are buried six feet deep, so they're going to be groundwater temperature, right? One thing to note for anybody in the colder climates, we kind of mentioned, hey, you can put these pretty much anywhere you need to. There is a special valve kit that is made in case the line were to freeze. We have heat tape on it to hopefully protect that, right? And we can control that heat tape with a thermostat. But in the event that there's a real problem, we don't want this unit to freeze and break. So there's a specialized valve system that you order with the kit, with the water heater system.
That drains the water out of the unit.
Automatic drain on the water if it gets to a freezing temperature.
Oh, interesting. That's cool.
And you have a generator here, so the fact that you can run your heat trace if you need to in a backup power situation, if you did lose power, that's another kind of a benefit that allows you, to use a unit like this.
Lastly, footprint. It's tiny, right? And you didn't have to have a large room for your heat pump water heater because it being a split system, we don't have to have the volume in the space to worry about that heat exchange.
And no noise inside the house too. That tank is just a dummy tank with water flowing through it. You don't hear a thing in there.
Yeah. What's great about hydronic systems, but that's what this is they're silent.
Yeah. Pretty amazing. Let's go back to the studio and wrap it up, boys.
Awesome.
Ready? All right, see you back there.
That's a really, really good unit there. And we also can take it one step further with air-to-water heat pumps or with geothermal heat pumps, right? So in this case, you're looking at a geothermal water-to-water ground source heat pump. The water pipes come in. We have a chill water tank that stores 45-degree temp. We have another storage tank here for the heating buffer. So this is going to be about 120 degrees. But the domestic goes through the inner coil and then gets reheated if it needs to by the heat pump water heater. So we call this kind of like a preheat reheat. So you get the kind of the best of both worlds with an all-electric system in this case, where you can let the air-to-water heat pump or the geothermal heat pump do the majority of your heating. The water in our climate goes in at 40 degrees. In this case, it might come out at 90 or 100 degrees. This unit just does the final top-off if it needs to, and then it goes out to all the fixtures with nice domestic hot water.
That's pretty cool.
Yeah.
Guys, let's wrap it up here. We spent a fair amount of time talking about how to make hot water and how to make sure we don't run out of hot water. Any final takeaways for you, Eric, after thinking about all these systems?
There's a lot to choose from. My approach typically in the retrofit market is going to be fuel source, what's going to fit best. And then, of course, I mean, the reason why we're talking about this in the first place is it going to perform for my customer? Because I can't tell you how many calls I've got from customers that are very upset about cold showers. I don't like cold showers. I know you guys don't either. I don't know anybody that really does.
Yeah. Ross, I'm curious, we looked at the engineering on my house and you were able to calc it out and the real world turned out pretty dang close to your calcs, I would say, within 10% maybe.
That's right.
Is that true also when you think about all the systems you've designed when it comes to hot water? Are you getting callbacks occasionally or almost never on running out of hot?
Well, it really depends on the design and the application. But if we got the design right, if we know the application in terms of how much hot water we're using, we get that sizing right, the math doesn't lie, right? It works and it proves itself out. So we have endless hot water if we design it that way based on the client demands, right? If you have those body jets and the rainfall shower head, you got to take that into consideration. You got to do the math on that. And our client expectation sheet that we have every client fill out is how many showers do they run simultaneously and for how long. That's really the real big driver for hot water use is showers. So we just want to make sure we nail that down, know the fixtures in terms of how much hot water they're using, and then we can size it right.
I'm so glad you mentioned that client expectation because I think we should end with this. Understanding what I'm going to build and the use cases and what they're doing makes such a big difference in making sure I don't run out of hot water. If I'm building a lake house for a couple that has 3 or 4 kids that have 3 or 4 kids and they're coming back, I'm doing a very different strategy than if I'm building a 2,000 square foot house for a retired couple with no kids, let's say.
Yeah.
It's a whole different deal. And so that plus knowing, hey, this is a body wash that has these jets, that has this or that. These are the flow of the fixtures. I think what we want you to take away from this is to plan a system correctly, we really need to understand what's the use of the house. And then also we need to think about future proofing a little bit. When I built my own personal house, I was thinking, my kids are in their teens. In another decade, they might be married and have a kid or two. And so my use case is going to change. So I built in a little bit of buffer in several areas. Plus, I didn't put a single body wash in. I didn't want to do that. I've only got regular Kohler 2.2 GPM shower heads in my house. So I knew exactly what I was going into. And I think it makes a big difference.
It does. A lot of these houses stay the same for a very long time. If you're going to retrofit in the future, way down the road, We're probably gonna have to look at equipment, and by then it may have changed.
Yeah.
That's right.
And the last thing I want to leave you with is consider adding both gas and electric for your locations. You know, where my water heater is at my house, I'm not making any hot where that tank is, but I put a 220 line in there so that if someday I need to put an electric tank in or whatever, I've got that option.
Yeah.
I didn't put necessarily that same gas and electric in for my kitchen. I wish I would have. And I didn't do that in my laundry, but I really probably should have. So consider your water heater, your laundry, and your kitchen as places that you might want gas or electric.
Run both.
Run both.
If you can.
Run both. And as a final future-proofing note, I read a fascinating article recently talking about how we might be able to use all of our existing gas lines in America for a different type of fuel source in the future. And it got me thinking, that's such a fascinating. We'll see what happens if you watch this video in 2075, whether that happened or not. But I think trying to think as far into the future as you can. Guys, great episode. The three of us could talk about water heaters for another 3 hours.
A lot to talk about.
We got to move on. I think we've made a pretty good point here solving the first issue and the second issue. We still have a few more things to talk about though here on the Perfect Plumbing Plan. With that being said, we'll see you next time on the Build Show.
Perfect Plumbing Plan, a Build original series brought to you by SharkBite.